Welcome back. In this video, I want to illustrate with an example how the step-forward feature selection algorithm works. Let's imagine that we have a dataset with 4 features, which are these 4 colorful columns that we see here. The step-forward feature selection algorithm will start by building all possible models containing only one feature. So in this case, it will build a model for feature blue, one for feature orange, one for the brown feature, and one for the yellow feature. And then it will determine the performance of this model built on a single feature, and it will select the feature that produces the best performing model. In the second step, this algorithm will try all possible combinations of features with the orange one. So it will try a combination of the blue and the orange feature, a combination of the brown and the orange feature, and a combination of the yellow and the orange feature, which is what you see here. It will build one model for each of these 2 feature combinations. It will determine the performance of these 2 feature models, and then it will select the feature pair that returns the highest performing algorithm. In the next step, it will add one additional feature to this pair of features. So it will be the orange and the blue plus the brown or plus the yellow, which is what we see here. It will build one model for each group of 3 features. It will determine the performance, and then it will select the group of 3 features that produces the best performing model. And it will proceed on and on until it reaches the full set of features, in which case it will build a model as well and determine the performance. So you will see that as we increase the number of features, there will be an increase in the performance of the model, and very often in your datasets you will see that this increase in performance plateaus towards a certain number. The key here is to decide when the algorithm should stop adding features in the search. What is the optimal number of features for our model? In theory, or in the ideal scenario, when to stop the search could be defined by when the performance does not increase beyond a certain threshold, and the threshold is to be defined by the user. In practice, we're going to use the MLXtend implementation that stops when a certain number of features is reached, and this number of features is defined by the user. In the next video, we're going to see how to implement step-forward feature selection with MLXtend in Python.